What is going on, guys? Mr. C here with a lesson 11.1. So we are going to be jumping around a little bit these next couple weeks, just as we're trying to finish up just a bunch of random stuff before I send you guys off into the real world, as we'll say. Kind of sad because, you guys really only have a couple more weeks. I don't even really get to see you guys during this time. You just hear me blabber on. I'm not even sure if you guys are even watching these. Hope you are. But yeah, I'm sad that I don't really get to download into you guys the rest of whatever little wisdom I have for you before you go become adults and stuff. So kind of sad. But on a brighter note, uh, the idea is to watch Chicken Run this Wednesday during our Zoom time. So if you guys do have that time available or that time open, it'd be awesome. I'm going to try to stream Chicken Run over Zoom, and we'll hang out and watch the movie together. That's 12:30 on Wednesday. I'm really excited to do that with y'all. So let's go ahead and jump into the lesson. So system of linear equations, and you guys might even be thinking like, oh my gosh, this is in pre-calc, and it's so late in pre-calc. Isn't it supposed to get harder as the class goes on? Typically, this is kind of, again, the first section of a chapter, so they're typically refreshers. So let's go ahead. We're going to go over substitution and elimination today. So if you recall, a system of linear equations would be something like this. Here's our first example. Let's solve this thing. We have two equations. The first one is 2x plus y equals 5. The second one is negative 4x plus 6y equals negative 2. Okay, and we're trying to figure out for what value of x and y makes both of these equations true. All right, or if you want to think about it this way, these are two lines. We're trying to figure out where is their intersection. Okay, I don't know if those are actually the lines. Probably not, but that's what we're trying to find. So let's start with substitution first. Okay, if I want to solve a system of equations by substitution, I need to get one of the variables by itself. I'm looking at this y here because there's no coefficients. So I'm going to rewrite this equation, right? Move the 2x to the other side, and it should give me y is equal to a negative 2x plus 5. And then I can take what y is equal to here, this thing, plug that in for, plug that in for x in my other equation. I have a negative, for y in my other equation right here, because y is equal to this thing, not x, should be a minus 4x plus 6 times negative 2x plus 5 equals negative 2, and we want to solve this thing. Negative 4x minus 12x, make sure to distribute the 6. 6 times 5 is a 30, equals negative 2. This makes a negative 16x. On the right side, if I subtract a 30, that's a negative 32. Divide by negative 16. Negative 32 divided by negative 16 should give me a 2. Right? Once you find that, we plug it in for x up here. So y is equal to negative 2 times 2 plus 5, which is negative 4 plus 5 is 1. So we have two answers. Well, one answer in two parts. Y is 1, x is 2. If you want, you can leave it like that, or the point 2, 1 is also acceptable. All right. So if you wrote it as an ordered pair, or if you wrote them separately, doesn't matter. As long as you tell me x is equal to something, y is equal to something, that is an appropriate answer. All right. So that's substitution. Let's go ahead and do one by elimination. Okay, let's solve. We have 2x plus 3y equals 1. Negative x plus y equals negative 3. Oops, that was terrible. That was about to be terrible again. There we go. That'll work. All right. 2x plus 3y equals 1, and negative x plus y equals negative 3. Now, if you recall, in elimination, we're basically going to add the two equations together to get a new equation. Now, what we want to happen is that either the x's are opposites or the y's are opposites. Like we want a 2 and a negative 2, or a 3 and a negative 3. We don't have that at the moment, but what I could do is I could multiply this bottom equation by 2 to make a negative 2x. That way the x's will cancel. So let's go ahead and do that. Times 2. We will have a negative 2x plus 2y equals negative 6. My other equation was a 2x plus 3y equals 1. And we can go ahead and add those two together, and you'll see the x's, 2x minus 2x will cancel. 3y plus 2y is a 5y. 1 plus negative 6 is a negative 5. And you'll see if we divide by 5, we'll get a negative 1 for y. And then it doesn't matter, plug that y back into any of our equations up top. Let's say here, negative x plus negative 1 equals negative 3. I plug that here for this equation. That's right now a negative, I need to add the 1 to the other side, so negative x equals negative 3 plus 1 is a negative 2. Divide by a negative for a negative 1, x will equal 2. Okay. So x is 2, y is negative 1. You can write that as 2, negative 1 for your solution. All right. Okay. Really only one other thing I want to touch on, and that's in the cases of infinite solutions or no solutions. So if you recall, you're going to have infinite solutions when again, remember what we're solving. You're going to have infinite solutions if, say, this line and your second line is the same line. Okay, so we have that black line and that blue line. If your lines are the same, you have the same equation, you're going to have infinite solutions because those lines are intersecting everywhere. So if you notice that both the equations are equivalent, maybe one is just a multiple of another or something like that, then you will get this here. So there's one other case where you have no solutions, and that's when your lines are parallel, but they have a different y-intercept. They're not right on top of each other. So if you had a case like this here and this here, kind of look parallel. They look a little bit off, but if these lines don't ever intersect, their slopes are the same, you will have no solutions because they're never going to intersect. An example of that as an equation would say be 3x plus y equals 7, and then you have 3x plus y equals 17. Okay. If you moved the x's over for both of those, you'd have a negative 3 slope. They would both be the same, but the y-intercepts are different. Okay, so that would be an example of no solution. Right. Okay, that is all I have for today. Pretty short lesson. Make sure to join us Wednesday Zoom at 12:30. Bring some lunch and enjoy some chicken run. Looking forward to seeing you guys. All right, talk to you later.